Hello. So this is a overview of programming math functions and strings and outputs in Python. So this is a continuation of our printing function and our output function. So throughout this, you have been doing math the hard way. So addition, subtraction, but there are other built-in functions that Python uses. So these functions, a max, a min, rounding, absolute value, power, it's all these functions that work on your calculator, but Python does the same thing. So max and min, if you give it a list of numbers, it'll find the max or the min, the minimum. Rounding rounds to the nearest integer. So the 3.51 will round up. The 3.4 will round down. Absolute value, ABS, returns a positive result. And the POW function, the POW, is the same as using the double asterisk. So you've actually been using built-in functions. The turtle function is actually a built-in function, and you have to invoke that when you start your program. And you do the same thing with the math function. So you have to start your program with import math. So the following is just an example of importing that math function in the other functions that you have. So these are all of the different functions that you can, just a couple that you can actually use when you are using the math function. There's things like ceiling. So ceiling, it always rounds up. Floor, this one right here, that always rounds down. Exponents and logs, you'll learn about that when you get into Algebra 2 or Pre-Calc, but you'll remember square root, SQRT, sine, cosine, tangent, inverse is the A, degrees, radians. These are all math functions that are built into Python. So to do that, you always have to start by importing math, and then you can test these things. So I think the easiest one to understand here is print, and then it's SQRT, and then the float variable there, the 4.0, and it will do, right, it'll print this, and then it will do the square root of 4. What you'll notice is, just like in Turtle, if you're using that function, you need to call that function each time. So math and then square root of 4, and you can see the input, or the output here is, it will print out the square root of 4 is 2. Okay. So there's a little case study that I will have you complete on this. So the other part of this is outputting and kind of organizing strings. So whenever you are organizing a string, string is just a text. You can either use a single or a double quotations. They mean the same thing, but generally you use a single quote for a character, one character like A, and then the quotation marks for the longer strings. Okay. The other thing with this is the strings are actually bits of code. So the reason why we do this is the computer doesn't understand that A is A. Is A capital? Is it lowercase? Well, they have these things it's everything is stored in a byte, and they use Unicode or ASCII to then be able to translate a capital A or a lowercase a into something that's usable for the computer. So remember, computers use ones and zeros. So we have to encode and decode things all the time. So each character that we have is associated with a number, and that number is then associated with a binary code that then can be read by the computer. So we have to translate between all these different languages all the time. What you'll most likely only see on your end is ASCII 2. Okay, so I just put a list. There's millions of commands in ASCII. I put the printable list. So, like a spacebar is associated with the number 32. The capital A is associated with the number 65. The lowercase a is always associated to the number 97. So you'll notice that it has all 26 letters here. Okay. These capitals and lower cases are separated by the same amount each time. So those 32 characters, because after the capitals, you have the left bracket, the forward slash, the right bracket, the caret, as I call it. All right. So order, okay. Order is this number, okay, and character is the output, okay. So in Python, ch. So let's say just ch is a. Okay, so that's a variable ch, right? If I ask for the order, is 97, because that is the number associated with the lowercase a. So then if I ask what's the character in order, what's the character associated with the number 98, I go, 98. Oh, that's lowercase b. That is what Python is doing. It is reading, do you want the number, the order, or do you want the character associated with that number? Also, when you're programming, again, these are special cases and characters. So let's say you want to print something, and it is all one line. So I have a print, Mr. Parsons' sense of humor is awesome. Computer science, sometimes it's funny, said no one ever. So if I want to print that sentence out, and I want it on 2 lines, I need a quotation mark so that I know that this is possessive. There, with the double quotes and the single quote, sometimes Python reads that as text or string. So we have to signify to the computer that it is just reading this as a text, not to read it as the end command. Also, if I want to print things on the next line, or tab or space things between words, I need special commands for that. So that's where you have this \n, which is a new line, next line, this isn't backslash, this is / t, adds the next tab position, so those 5 spaces, / single quote or double quote, if you need to quote someone, is that /. So you'll notice I created this code here, and it's just print, and it's all just one line, and I put those /, the / n here, the / double quotes here, and then the tab right here. You notice how it printed out. You do not see the / after awesome. It goes to another line. Again, it does not read that / It puts the quotation marks there. Here, it puts the tab space. And then this is my start. That's my start and end of that whole sentence. So just different ways that you can output text. The other way to format text or strings is to use the end function. So you have an item, and then you put a comma, end equals, and then how do you want to end that string? So this, right, anything in these quotation marks, it'll print what you want. So you plug this in, it prints a space after the three A's, no space after the B's, 3 stars after the C's and D's, and then basically I just put that in there. So you'll know that after this, it'll print anything you want after the string. The sep function separates two items with whatever you want. And this happens when you want to input a lot of data. So this one right here will separate the A's and the B's with a space, 3 stars, and it will just start and end, and then I put the stuff in the beginning. So the other thing is with all these outputs, is it a string? Is it a character? Is it a number? That sort of thing. So we have to tell the computer what is going on. So this, right, STR stands for string. So instead of reading this as a number 3.4, it reads it as the text 3.4. So it'll print out the text. If you want just 3, it'll print out 3. If you want to combine different things together, this is where the space comes in sometimes. So let's say, this is a simple message, right? Welcome to Python. It'll print out welcome to Python. But let's say you are asking a user, please input 3 different colors. And you ran color 1, color 2, color 3. And then those are all variables that then are input by the user. So then you would use the plus sign to separate them. And you could print out an output that says the three colors you entered are color 1 plus color 2 plus color 3. End it, and it'll print that out for you. Just like here. So chapter number equals 2, S equals chapter plus the string of chapter number. Boom. That is how you separate that out. So that's exactly what I'm talking about. The input with the output, it'll print out and combine your variables. You'll notice that once you input this, you do not need quotation marks. If it is the variable, it'll print it out as a string. If you just have the input function here. Remember, if you put the eval, EVAL, in front of it, it reads it as a number. So you will complete this case study before you move on. So everything, it's just numbers and strings, okay? So you can perform operations on different numbers and strings. We're just going to keep it simple for right now and use kind of the methods lower and upper. Okay, so lower, right? So S dot lower, it's invoking the lower method. It takes this and converts all of these characters through using that ASCII key to lowercase letters, while the dot upper will convert all these letters to uppercase letters. So there's different methods that you can use on strings to change the formatting, and that's the big part of this chapter is the formatting. Again, strip strips out white space. So if you remember, this /T creates a tab space. Those are white spaces. So the strip function means that it's going to strip away all the white spaces so that it is just the text. So you'll notice that if I print this out, okay, there is no more white space in front of this. It is not tabbed over. And then there's also other formatting issues. So if you have a specific number of decimal places that you need, a specific number of characters, that sort of thing, if it's scientific notation, you use the format function, the item, and then how you want it. So if I'm printing the format, okay, and this is my item, this number, this first number tells me how many characters long it is. So in this case, it is 10, okay? How many decimal places I want. In this letter right here tells me if I want it in decimal form, in float form. It tells me generally what I want the output to look like. So in this case, I want this number 10 spaces long. So you'll notice, right, I had to add 5 spaces of white space in here because once I knock this down to 2 decimal places, there's 1, 2, 3, 4, 5 characters, leaving 5 characters in front. In here, if I do the same formatting, I'm doing it to 2 decimal places, this 9, 2. Well, there's already 10 characters, so there's no white spaces in there. If I have, this only has 1 decimal place, but I wanted 2, it adds a 0 in there. And the same thing with no decimal places, it adds those 2, and it'll have 5 white spaces in front. The E is for scientific notation. You'll notice this when you deal with big numbers on your calculator. So it converts it to scientific notation, 2 decimal places. Again, that 0.2 is the 2 decimal places. E tells you to what power. So 5.75. E1 means it's times 10 to the first. If you don't remember scientific notation, we can do a whole other lesson on that. The percent obviously gives you a percent, but it does add a character value to it. So the 0.53457, again, it's 53%. I want 2 decimal places, so 34. Percentile, you'll notice the percent is a character. I want this 10 characters long, so now there's only 4 characters in front because this counts as one of those spaces. And it goes through all of these. And then you know how you have a right and left justified. Everything is generally left justified. Otherwise, if you put this symbol in front of it, then it is right justified. The D, okay, is what you'll normally use. The D is the decimal. We are not going to use hexadecimal, octagonal, or binary. So here's some more examples of this. You'll notice that it does not have the number in front. That just means that it's just going to format the decimal places. It's not going to care about how many characters long it is. It's just going to care about the decimal places. So this 0.678 goes to 0.68 because it's going to round up. While if I just do 1 decimal place, this becomes a 7. Same thing through here. And then this is where that D comes in on the bottom. You'll notice that it adds that comma in between because it prints it as a decimal form. So it adds that spacing in there. And this is where you can see really the spacing here. So it needs 12 characters. And this is really only 1, 2, 3, 4, 5, 6, 7, 8 characters long. So it added 4 spaces in there. So if you want this next to the is, you might also invoke that strip function to strip away those white spaces. And you can also format strings the same way. You have the S here, and this is the left and right justified, and this tells you how long you want that string to be character-wise. So it'll add white spaces in front, behind, or in front, depending on how you justify it. Thank you, and refer to this slideshow or the textbook for any other examples.